Assalamu alaikum wa rahmatullahi wa barakatuh. Yesterday we have studied about the absolute pressure and gauge pressure in previous video. Now we are going to learn about a new concept, that is hydrostatic paradox and Pascal's law and its application. Okay, so in this video we observe that after application of the pressure on the left side, the liquid level rises in three columns of different shape. So depending upon the shape, we can feel that height of liquid column in column A should be more as compared to height in that of the B and C, as its cross sectional area is small, whereas height of the liquid in column B should be less as compared to A and C, as its cross sectional area is more. But we notice that liquid rises to same height in all three columns. So this is a opposite, that is called as paradox. So it is clear that pressure in the column depends upon height of a column. This is called as hydrostatics paradox. Okay, now we are going to learn a next point, that is Pascal's law. What is Pascal's law? It states that a pressure applied at any point of an enclosed fluid at a rest is transmitted equally and undiminished to every point of the fluid and also on the wall of container, provided the effect of gravity is neglected. That means when we apply the pressure at any point, the pressure is transmitted equally at all the side of a container without changing the shape. So it is said that transmitted equally and undiminished, okay, without changing the dimension to every point of the fluid and also wall of the container where the effect of gravity is neglected. Let us see this by a short experiment. Okay, we will have one activity, perform one experimental activity. In that we will see the Pascal's law. We will try to understand clearly the Pascal's law. So let's see it experimentally. We will perform one small activity. For that we require one bottle, one 5 ml syringe and 4 3 ml syringe. So I am taking one bottle and making a hole in the cap of the bottle to fix 5 ml syringe in it, and making same 4 holes in the bottle for fixing 3 ml syringe. Now I will stick all the string with help of a hot glue gun and fill the water in the bottle and also in 5 ml syringe, and I will fix a cap. Okay, so now when I apply the pressure on 5 ml syringe, which is at the top, that is in the cap of a bottle, you can observe, you can notice that all the syringe pistons push outward equally. Okay, and when I pull it upward, that time all 4 syringe pistons are pulled backward. This verifies the Pascal's law, that is, a pressure is transmitted equally at all sides of the container without changing the shape of the container. So the next concept, that is hydraulic lift. Okay, so consider a system containing a fluid in it as shown in the figure. Two pistons A and B having cross-sectional area A1 and A2 are fitted at narrow and wider end as shown in the figure. We can see that area A2 is greater than that of a A1. When we apply a force F1 to a smaller piston A in downward direction, it generates a pressure that is equal to P equal to F1 upon A1, force upon area, which is transmitted to undiminished bigger piston B. So now force acting on the piston B is F2, that is nothing but equal to pressure P into A2. Okay, so but what is pressure P? F1 upon A1. So if you put the values, we get F2 is equal to F1 into A2 divided by A1. So from this we can see that force F2 is much larger than F1. As force F2 is larger on piston B, the piston B is lifted upward and can be lifted upward very easily if we just apply a small force on a piston A. So a heavy load placed on piston B can be easily lifted by applying small force on a piston A. So this is a working mechanism of a hydraulic lift which is mostly used in a car garage to lift the heavy vehicles. Next concept is hydraulic brakes. Hydraulic brakes are used to slow down or stop the vehicles in motion. The mainly two types of drums which are used in the vehicles are disc brake and drum brake. Okay, so how does they work? Okay, let us see. When a driver press a brake pedal, the piston of a master cylinder is pushed in forward direction. As a result, piston in slave cylinder, which has a much larger area of cross section as compared to that of master cylinder, also moves in forward direction so as to maintain a volume of a oil constant. The slave piston push the friction pad against a rotating disc which is connected to the wheel, thus causing a moving vehicle to slow down or stop. Okay, so this way hydraulic brakes work. Here what happens, when a brake is applied, the piston in the main cylinder called as master cylinder is pushed forward. When it is pushed forward, the pistons which are attached to the slave cylinder, okay, which are indirectly attached to the braking system of the four wheels, okay, that too are pushed forward. As a result, what happens in a drum brake, there are two C-shaped disc. Okay, in that this piston is connected to these two discs and these two pistons in between are connected by the spring. So when a driver applies the brake, the piston is pushed forward. As a result, fluid in which is connected to the disc increases the size of that. As a result, the two C-shaped discs which are attached in the drum, they get attached to the wheels of the vehicle, axle of the vehicle, and make a axle to stop. Okay, thus it slows down the speed or it stops the vehicle.